Okay, so I think we're discussing about porosity. Okay, so porosity, I think we have already covered what you mean by porosity. So porosity in another just and then it is a percentage of void space in a rock or a rock void space. Okay, in a rock, if you take the total void space, you can see in this figure there is a lot of void space here. So here there is a void space, here there is a lot of void space. Okay, so percentage of it. So you void space in the percentage. Okay, the percentage of this void space. Okay, is called as porosity. Okay, so I think we have just started porosity, right? We have not explained about the factors affecting porosity. ഇതൊന്നും പറഞ്ഞിട്ടില്ലല്ലോ. ഇല്ല എന്നാണ് ഞാൻ വിശ്വസിക്കുന്നത്. Okay, so we have just started the porosity, I think. ഈ PPT പറഞ്ഞിട്ടില്ലല്ലോ. Okay, now next is factors affecting porosity. Okay, what are the factors which is affecting porosity? So first one is particle sphericity and angularity, packing, sorting, cementing materials in all burden stress. Okay, so what are the എങ്ങനെയാണ് porosity വരുന്നത്? What factors lead to porosity? Okay, so first one is particle sphericity and angularity. Particle sphericity means from this picture you can see this particle is having a spherical shape, but this particle is not having a appropriate spherical shape. In somewhat you can say rectangular or the shape. This is somewhat spheroidal here. This is again, this is not also spheroidal. Okay, the different shape particles will be having different shape. That is sand grains. Okay, so their particles will be having different shapes. If you take a rock mass also, our particles will be having different shapes. Not every particles will be correctly round. So if you take a sand back, okay, oru sand its shape will be different. Not like it's very minute. Actually, some will be very round, some will be angular, some will be sphericity. So the different shapes, okay, this different shapes and difference in the sphericity of these particles will actually leading to the void space. So you can see from this picture, okay. So this is one spheroidal particle and this is some rectangular particle, okay. So when these two people, so when these two particles come together, you can see a void space is created in between. നോക്കൂ അങ്ങനെ ഒരു സ്പിറോഡൽ ഷേപ്പും ഒരു റെക്ടാങ്കുലർ ഷേപ്പും ഉള്ള ഒരു സാധനം അടുത്ത് വരുമ്പോൾ you can see what will happen, a void space will be created in between. Okay, we can see here. Okay, between these two particles, there is a void space, and also between these two particles, there is a void space. ഇതുപോലെ different shapes because of the particle sphericity and angularity, difference in the angle. Okay, difference in the angles of the shape. You can see, ഇവിടെയുള്ള എല്ലാ particles they are having different angles. അല്ലേ എല്ലാവരും correct round ആണ്. No, it's not correct round. Okay, so difference in these angles and difference in the spherical shape of these particles will actually lead to the creation of the voids between them. Okay. Second one is packing. How they are packed. Okay. Sometimes the particles will be very tightly packed. Here you can see these three particles are very tightly packed. Okay, these three particles are very tightly packed, so the voids between them is very less. If you see here, this particle, and this particles, okay, loosely packed down. Okay, these three particles loosely packed. And മൂന്ന് particles മൂന്ന് സ്ഥലത്താണ്. So because of that, their void space is large. Okay, the space between the particles is large. Okay, so that's the second point, that is packing. That how they are packed. If it is loosely packed, the void space will be more, and if it is tightly packed, the void space will be less. Third one is sorting. Okay, that is variable grain sizes. That is the same thing that we have said. Okay, for particles you will be having a grain of different sizes. Okay, you will be having, okay, if you see here, you can see sand grains of different shapes will be there. Okay, okay. Sometimes ഒരു മാൽത്തര എടുത്തു കഴിഞ്ഞാൽ, like if you see another one example I can say is that if you take some metamorphic rocks, okay, so metamorphic rocks എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is actually formed by several minerals. It will be having calciums, it will be having potassiums, okay? So this calcium, potassiums, all this lime, these all will be having, these minerals will be having different shapes. Okay? So metamorphic rock എടുത്തു കഴിഞ്ഞാൽ പല ടൈപ്സ് ഓഫ് മിനറൽസ് ആണ് അതിലുള്ളത്. ഓക്കെ, ചിലപ്പോൾ കാൽഷ്യം ഉണ്ടാവും, പൊട്ടാഷ്യം ഉണ്ടാവും, ചിലപ്പോൾ അതിനകത്ത് ലൈം ഉണ്ടാവും. ഓക്കെ, അപ്പോൾ ഈ ഗ്രെയിൻസ് വിൽ ബി ഹാവിങ് all these items will be having different shape, variable shapes will be there. Okay, so in this diagram you can see that this is a sand grain, this is a cement. Okay, so this is കുറച്ച് sand ആണ്, കുറച്ച് cement ആണ്. So size of the sand is different from that of size of a cement. Okay, so that is sorting. You will be having variable grains, you will be having different items. Your rock, it is not composed of a homogeneous material, it is composed of a heterogeneous materials. Okay, next one is cementing materials. Okay, cementing materials means എങ്ങനെയാണ് രണ്ട് പാർട്ടിക്കിൾസ് തമ്മിൽ സിമെന്റ് ചെയ്തതെന്ന് വെച്ചിട്ട്. Okay, so there will be some particles where adhering will be more. If you take clay, okay, so clay means it adhering will be more, its sticking capacity will be more. അത് ഒട്ടിപ്പിടിക്കാനുള്ള ആ ഒരു ടെൻഡൻസി വളരെ കൂടുതലാണ് if you take clays. Okay, at the same time if you take any other like pebbles, they won't stick together. Like pebbles ഒക്കെ എടുത്തു കഴിഞ്ഞാൽ നല്ല മഴ വന്നാൽ നല്ല കാറ്റ് വന്നാൽ they will separate and they will flow. Okay, so that is cementing materials. Okay, so if you are taking clay, so claysലൊക്കെ എടുത്തു കഴിഞ്ഞാൽ clay എടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ porosity will be very less. Why? Because അവിടെ particle cementing is more, because they will be very tightly packed. അവരുടെ ആ രണ്ട് പാർട്ടിക്കിൾസ് തമ്മിലുള്ള force of attraction is very more. The cementing between the particles is very high. Okay, but at the same time if you take some pebbles, okay, pebbles എടുത്തു കഴിഞ്ഞാൽ അവിടെ force of attraction between the particles is very less. Okay, force of attraction between two particles are very less. That means cementation is very less. Cementation means stick ചെയ്യാനുള്ള ഒരു capacity cementation വരും. Okay, so that is very less. Coming to fifth one, that is overburden pressure or compaction. Okay, so overburden pressure, what do you mean by overburden pressure? So you can see here in this figure. Okay, so if I am taking this figure, you will see in the figure. Okay, so this is a sand grain. Okay, so here suppose if I am applying a load, so how the load is applied? Maybe a layer of sand in the middle, you are having a vehicle is long. Suppose a vehicle in America. Okay, so what will happen? You can imagine ആ താഴെയുള്ള മണ്ണുണ്ടാവും, കുറച്ച് കോമ്പാക്ട് ടൈപ്പ് ഉണ്ടാവും. Okay, if the vehicle is there, what will happen? The soil below will be compacted. Suppose if this above ഒരു sand layer in the top layer you are having a building. Okay, so what is actually building doing? Building is actually exerting pressure on the compaction pressure on the soil. So because of that pressure, what will happen? Because of that pressure exerted by the building, the void spaces between these two particles will be lost, and these two particles will come close to each other. Normally that is what happening. Whenever a load is applied, that is if there is any kind of vehicles or if there is any building, what will happen? The building or that load will exert a pressure into the ground, and this soil and this soil particles, it will combine together. Yes, combine together, and that void space will be lost. That we can experience. Sand, if you take a sand and if you add water on it, and if you press, okay, if you tightly press on top of that soil, what will happen? It will compact. How the compaction is occurring? Why? Because the void spaces between the soil particles is lost. Okay, the soil particles അടുത്ത് വരുന്ന സമയത്ത്, if it is tightly packed, അതിങ്ങനെ അടുത്ത് നിൽക്കുന്ന സമയത്ത് എന്തായിരിക്കും? The compaction occurs. So that is where the compaction occurs. So that is overburden pressure. overburden pressure or overburden stress. So these are the factors which is affecting porosity. So mainly we are having two types of porosity. First is primary porosity and secondary porosity. So what do you mean by primary porosity and what do you mean by secondary porosity? So the primary porosity means porosity that is formed at the time of deposition. Okay, when the rock is actually formed by the weathering of particles. Okay, weathering of particles. So what is actually weathering? We have studied what is weathering. Weathering due to the atmospheric agents, sediments deposit ചെയ്തിട്ട് ഉണ്ടാവുന്നതിനാണ് നമ്മൾ weathering എന്ന് പറയുന്നത്. Okay, so that deposition, weathering the സമയത്ത് the deposition process is there. Okay, so that porosity which occurs, or we can say the voids which occurs at the time of deposition is called as primary porosity. അതായത് weathering നടക്കുന്ന സമയത്ത് റോക്ക് പാർട്ടിക്കിൾസ് ഡെപ്പോസിറ്റ് ചെയ്ത് പോവുക ചെയ്യുന്നത്. അപ്പോൾ ആ ഡെപ്പോസിഷന്റെ സമയത്ത് ഉണ്ടാവുന്ന voidsനെ is called as primary porosity. Okay, so what do you mean by primary porosity? Primary porosity is a porosity that is formed at the time of deposition. Now coming to the secondary porosity, that is which is developed after the deposition of the rock. That is once the weathered materials has been deposited, after years and years it will be forming into some either some hill or it will be forming into some rock mass. Okay, so that time the porosity which occurs is called as secondary porosity. Okay, so what do you mean by secondary porosity? Secondary porosity is the porosity which occurs after the deposition of the rock. Okay, during the weathering, what is happening? The weathered particles are deposited, and after years, these particles will form into some kind of rocks. Okay, our time, the porosity which occurs is called as secondary porosity. That is, after the deposition of the rock, if porosity occurs, it is called as secondary porosity. So next is so this is not much important. That is the another type of porosity: total porosity, effective porosity, microporosity, mesoporosity, macroporosity. Okay, so this is not much important as point of view, but you can just know what it is in case if they ask. Okay, so primary and secondary is important, but this is not much important. Okay, so total porosity means the ratio of entire pore space in a rock to its bulk volume. Okay. So total porosity means that is it is a ratio of entire pore space in a rock to its bulk volume. Okay. To the total volume. Our ratio we are calling it as total porosity. Okay. Now, effective porosity. Effective porosity is actually a measure of void space that is filled by recoverable oil and gases. Okay, so we know that in the stones, okay, in some stones there will be oil and gas content. Okay, so we know that in Dubai, not in Dubai, in our Mumbai also there is oil plants. But we are actually digging deep into the oil wells and we are actually taking oils out. So oil wells means basically the rock and rock കുഴിച്ചിട്ടാണ് അതിൻ്റെ ഉള്ളിലാണ് you taking oils out of it. Okay, so that means that rock അല്ലെങ്കിൽ that bulk mass of that that rock mass is actually contain oils or different types of gases. Okay, so effective porosity means the measure of the void space that is filled by the recoverable oils and gas. Okay, ഒരു റോക്ക് മാസിനകത്ത് അതിൻ്റെ വോയിഡ്സിൽ ഫില്ല് ചെയ്തിട്ടുള്ള ഓയിൽസിൻ്റെയും ഗ്യാസിൻ്റെയും മെഷറിനെയാണ് കോളിംഗ് ഇറ്റ് ആസ് effective porosity. Okay, so don't get confused. Effective porosity means the void space that is filled with recoverable oil and gas. Please know this. This is recoverable. Okay, that means oil that can be extracted. Okay, നമുക്ക് extract ചെയ്യാൻ പറ്റാത്തതല്ല, oils and gas that can be extracted. That is called as effective porosity. Okay, rock mass in the void space ലുള്ള ഓയിലിന്റെയും ഗ്യാസിന്റെയും measure. We calling it as effective porosity. Micro porosity. Okay. Okay, micro porosity means if the rock mass is containing pores which is smaller than 2 mm in diameter, it is called as micro porosity. Okay, if a particular rock mass is containing a pores അല്ലെങ്കിൽ void spaces smaller than 2 mm in diameter, is called as micro porosity. And mesoporosity means if the pore space is greater than 2 mm and less than 50 nanometers. Okay, sorry, this is not 2 this is nanometers. Okay, if it is greater than 2 nanometers and less than 50 nanometers, it is called as mesoporosity. Okay, this is also nanometers, not mm. Okay, this is nanometer. Okay, so mesoporosity means the void space which is having a size greater than 2 nanometers and less than 50 nanometers. Then the 2 into 15 it is called as mesoporosity. And if the void space is greater than 50 nanometers, so the void in the size it is greater than 50 nanometers, you will call it as macroporosity. Okay, that is macro, meso, and macro. That is based on the size of the void spaces. Okay, if the size is less than 2 nanometers, it is called as microporosity. If the size is between 2 to 50 nanometers, it is called as mesoporosity. And if the size is greater than 50 nanometers, it is called as macroporosity. Okay, now coming to the next one, that is permeability. Okay, so that's about the porosity. Now next one, coming to that of permeability. What is the permeability? So porosity and permeability is actually a connected words. Okay. So porosity means what? The void space between the rocks. What do you mean by permeability? Permeability means what? It is the property of the porous medium and is a measure of the capacity of the medium to transmit fluid. Okay, please note this word. It is a capacity of the medium to transmit fluid is called as permeability. Okay, see this figure. Okay, so this is different types of rock particles are there. Okay, this is different types of rock particles. Void spaces are between. See, this is the void spaces. Okay, and some kind of fluid is flowing between them. See here, the fluids are flowing with it. You can see the fluid is flowing. Okay, so the capacity of a rock mass to transmit the fluids between them is called as permeability. വെള്ളം കടത്തി വിടാനുള്ള വെള്ളം പറയില്ല, just fluids. Okay, fluids കടത്തി വിടാനുള്ള റോക്ക് മാസിന്റെ capacity, we are calling it as permeability. Okay, so what is the permeability? It is the property of the rock mass to conduct fluid between the pore spaces. Okay, അതിന്റെ പോർസിലൂടെ വെള്ളം കടത്തി വിടാനുള്ള അതിന്റെ capacity, we are calling it as permeability. Okay, so please know the difference, don't get confused. Permeability means the ability of a rock mass to transmit fluids. Okay, transmit fluids, this is the important word. How much of fluid can be transmitted through a rock mass, that measure is called as permeability. So you see that in some rocks it will be very permeable, some will be low permeable. Okay, so different types of rock we actually measure it. Some rocks it will be heavy. If you take clay, okay, it is a low permeable material because it won't allow the water to pass through it. So we can say clay is a low permeable material. Coming to, if you take a bunch of pebbles, if you take, like, this is a pebbles, right? If you take a bunch of pebbles and if you pour water on it, the water will pass through. That means it is having a high permeable. It will allow the water to pass through it. Okay. So the transmission of water, I mean, what transmission of fluid is very high. Okay. So permeability is an intrinsic property of a porous medium. Okay, it is a so you can see this. This is actually a picture which is taken in the microscope. With the naked eye, you cannot see this picture. Okay, so you can see it is in a rock mass. You can see the pores. Okay, see the pores. Okay, here also we are having three types of permeability: absolute permeability, effective permeability, and relative permeability. Let's see what's the difference between this. Coming to the first one, absolute permeability. So it is a permeability of a porous medium with the only one fluid is present, which is also called as a single phase flow. Okay, so it is a permeability of a medium which contains only one fluid. Okay, what are the type of fluid in download? Okay, which actually contains only one kind of fluid. Okay, so this rock mass, or we can say, or this medium, which allow the passage of only one fluid. It's called as absolute permeability. Okay. So this you might have seen if you see some wells. Okay. പാറക്കെട്ടുകളുടെ ഇടയിലൂടെ ഒഴുകി വരുന്ന വെള്ളം. Okay. So only water is coming through it. Nothing else is coming through it. That is a single phase flow. Only water is coming through the rocks. Nothing else is coming. So that is absolute permeability. That is, it allows only one kind of fluid, the flow of one fluid. That is single phase flow. Effective permeability. If two or more fluids are present, the permeability of the rock to the flowing fluid, it is called as effective permeability. Okay? If two or more fluids are present, some rocks will allow two or more fluid flow. Or you can say some rocks will be allowing the flow of two or more fluids through them. Such a permeability is called as effective permeability. This you might have seen in some wells. This you might have seen. ഈ പാറക്കെട്ടുകളുടെ ഇടയിലൂടെ ചില എണ്ണകളൊക്കെ പുറത്തേക്ക് വരും. It will actually contaminate the water. Okay? Not just the water, not just the pure water is coming, but between the rocks, some kind of oils will be coming. Okay? So this is actually make the it will actually lower the quality of water. So that means what is happening, that rock is allowing the passage of two or more fluids through them. That is called as effective permeability. ഒന്നിൽ കൂടുതൽ ഫ്ലൂയിഡ്സിനെ അലൗ ചെയ്യുന്നുണ്ടെങ്കിൽ that is effective permeability. Coming to the relative permeability, it is actually a ratio between the absolute and effective permeability. Relative permeability means it is actually a ratio between absolute permeability to effective permeability. Okay, we got it. Three types of permeability symbols. Absolute permeability means it allows only flow of one kind of fluid. That means in the wells, some rocks, that rock between the water that is coming from the rock will be very pure. Effective permeability means sometimes you can see some wells will be having bad water. Okay, you can see water which is not potable. Why? Because some other kind of fluid is also flowing inside it. That means a rock is allowing the flow of some other kind of fluids. So that is effective permeability. So another ratio between both you can say that relative permeability. The factors which is affecting the magnitude and permeability. Okay, so same as that is porosity. Porosity and permeability factors affecting our similar. So first one is shape and size of the pore system, same as that of porosity. Okay, shape and size. So what are the factors of the permeability? First point is shape and size of the pore system. Okay, pore system shape and size. Second one is sorting. We already discussed, same as that of porosity. Okay, cementation. Okay, how the if the particles are stick each other. That means if it is tightly packed or loosely packed, the capacity of the materials to pack to each other. Next is fracturing and solution. Okay, so this fracturing and solution means sometimes where the rock particles, it will be fractured. That is, a rock particles ഉള്ളിൽ വലിയ പൊട്ടലുണ്ടാവും. Maybe some due to some plate tectonic activities, or maybe due to some human activities, or maybe due to some landslides. Okay, the rock particles would have fractured. Okay, അങ്ങനെ fracture ചെയ്യുന്ന സമയത്ത് what will happen? The porosity will be more. That is, water below the rock will come through it, come to the pores of the, will come out to the pores. That is fracturing. Fracturing means what? The കുറച്ച് റോക്കിൻ്റെ അടിയിലൊരു പൊട്ടലുണ്ടാവും. So if there is any such a fracturing, the water will come out through it, or the fluid will flow through it. That is fracturing. Lithology or rock type, that is based on the rock, whether it is sedimentary rock, metamorphic rock, igneous rock, different rocks are there, and different rocks is having different properties, different materials, different composition, and their permeability and porosity will be different. Their wall spaces will be different. Okay, the mineral composition will be different. Their wall space will be different. Their permeability will be also different. So that is lithology rock type. Next is, where will you use this permeability? Why are you studying this permeability? So this permeability is mainly used to study the reservoir performance. Reservoir performance means sometimes if you want to construct any kind of dam, okay, you will be constructing a water storage structure. So that is called as reservoir. വെള്ളം സ്റ്റോർ ചെയ്ത് വെക്കുന്ന ആ ഒരു ടാങ്കിനാണ് calling it as a reservoir. Okay, so to study about the performance, you need the permeability. Okay, so what is that? Permeability is very important to study the reservoir performance. Okay, water storage in the ആ ഒരു ഇത് പഠിക്കാൻ വേണ്ടി. Reservoir means that is we are storing water. Okay, so that is that performance പഠിക്കണം. If the rock is permeable or not, whether it contains water or not, whether it is getting recharged or not. Okay, so all these things. So permeability is having a lot of importance in all this area. So you can see that the quality of reservoir is actually related to the permeability. So there are different types of reservoirs are there. Okay, so we will call the reservoir based on its permeability. Okay, that is, if it is permeable more than 10 D, it is called as a fair reservoir. And if the permeability is between 10 to 100 D, okay, high permeable, like you can say it's a high performance reservoir. And if the permeability is between 100 to 1000, it is very high performance reservoir. And it is greater than 1000 means exceptional reservoir. Sorry, it is less than 1000 means it is exceptional reservoir. That means the porosity is very less. Sorry, permeability is very less. So that means it can store more water. Okay, it can store more water. And one more thing, all these things, the data is like this, all these things, it will keep changing on for every 30 years. Okay, whatever the factors we are taking, whatever the factors we are considering for the construction of a dam, it will be changed after every 30 years. So as an engineer, it is your duty to check the renewed laws. Okay, എല്ലാ 30 വർഷം കൂടുമ്പോൾ we are having like research is going on each every field. Okay, for ഓരോ 30 വർഷം കൂടുമ്പോൾ some changes will be incorporated in the construction field. Okay, so that time you won't be able to study. Like ഒരു 30 വർഷം നടക്കുമ്പോൾ നിങ്ങളുടെ studies ഒക്കെ you will be into your work. Okay, so you cannot say that no, I have not studied that is not in my syllabus, I cannot do that. Our option ഓടെ വരുന്നില്ല. You have to You have to study by yourself. That is, you have to see what changes has been happened through all these years. What is a new thing? ആ ചേഞ്ചസ് എന്താന്ന് നോക്കിയിട്ട് അത് കറക്റ്റായിട്ട് നിങ്ങളുടെ പ്രൊജക്റ്റിൽ ഇൻക്ലൂഡ് ചെയ്യണം. That happens in every 30 years. So, next, that's a simple topic, that is porosity and permeability. Next one is Darcy's law. Who is Darcy? Okay. Who is Darcy? What is the Darcy's law? So see this figure first. Okay. First we must see this figure and then we'll discuss about Darcy. Okay. What you can see here in this figure, you can see water. Some kind of fluid is flowing through the particles, and here it is. This is the outflow, or you can say the discharge of the fluid. Okay. Two heads are here, H1 and H2. What actually, this is actually an experimental setup. Okay, this is actually somewhere we are in the lab, we are set up this kind of things. Okay, so these are rock particles, or you can say some kind of sand particles, whatever it is. Water is allowed through this particles. Water is allowed fluid. We will say fluid. Okay, we will say fluid. That's a general and safe word. Fluid is allowed through these particles, and between you can see some void spaces are there. See here voids are there. So through the voids, the fluid is flowing, and here it is outflow. Okay. So see this. Okay. So see this figure. There is one head and H1, H2. Now we'll go to the Darcy. You see what is Darcy is telling. Okay, you can post your name to mark the attendance now. Almost time now. So I'll be marking attendance based on this chat transcript. Okay, so please everyone has to post your name.